Welcome to This Explainer. Today, we're diving headfirst into one of the absolute most frustrating mysteries you can run into as a maker. I'm talking about that sudden, totally unexplained drop in your 3D print quality. You know the exact feeling, right? You've got your settings dialed in flawlessly, your printer's been humming along like a dream for weeks, and then, bam, out of nowhere, you're staring at a complete mess on your build plate. Well, we're going to use some real-world troubleshooting to uncover exactly what causes this, and more importantly, how to fix it. Just imagine the scenario. You've been printing perfectly. Your layers are buttery smooth, your bed adhesion is locked in, and you're feeling like an absolute 3D printing master. But then suddenly, your newest prints start turning out terrible. You're just standing there looking at your machine, completely puzzled. You haven't changed your filament brand, you haven't moved the printer, but the results? Yeah, they speak for themselves. Something has fundamentally changed, and you need to figure out what it is before you waste any more precious time and filament.
Okay, let's take a look at the actual evidence. This ruined PEGG print right here is our crime scene. If you look closely at that surface, it is just plagued by inconsistent extrusion. It's rough, it's irregular, and honestly, it looks almost bubbly or chewed up in places. If you're trying to print a precision part, a finish like this means that piece is going straight into the trash. So what on earth caused this? Section 1, Investigating False Leads. When you're faced with a ruined print like this, it's totally natural to start rounding up the usual suspects. Take the environment, for example. The filament used here is PETG, and if you work with PETG, you know it is notoriously hygroscopic. It absolutely loves soaking up moisture from the air. So if it happens to be, say, a damp monsoon season, your highly logical first guess might be that the intense humidity has compromised the filament, turning to steam in the hot end and causing that awful, rough extrusion. So, acting on that moisture theory, you start troubleshooting. You might try tweaking every possible setting in your Orca slicer to compensate. And when that doesn't work, you go to extreme lengths to dry the plastic. You might put the PETG in a microwave or bake it in the oven at the exact recommended temperatures to pull that moisture out. But this is where the frustration of false leads really hits you. Because after all that effort, you'll likely find absolutely nothing changed. The print still looks terrible. In fact, in this specific case, the only thing that provided even a tiny bit of improvement was drastically reducing the print speed. And you know what? That right there is our very first real clue.
Section 2, the hidden culprit, abrasion.
So if you've rigorously dried your filament and tweaked literally every software setting under the sun with zero success, it's time to pivot. We need to look at the physical hardware itself. And that leads us to our prime suspect, your printer's brass nozzle. This is the very last point of contact your printer has with the material. It's the bottleneck where all the magic actually happens. We often treat the nozzle like a permanent fixture, but taking it for granted, that is a massive mistake. To really understand the problem, we have to talk a little metallurgy. The vast majority of standard 3D printing nozzles are made of brass. Why? Well, because brass has excellent thermal conductivity, it melts the plastic super efficiently. But the trade-off is that brass is a fundamentally softer metal, and because it's soft, it is highly vulnerable to physical abrasion and wear over time. How much time? Well, the answer might actually shock you. We're talking about noticeable wear after just 100 hours of printing. Think about what that nozzle is doing during those 100 hours. It's constantly rubbing against the semi-solid plastic of the previous layer, and occasionally even grazing the hard build plate. Over time, that constant friction acts exactly like sandpaper, slowly and relentlessly wearing down the tip of that soft brass nozzle.
Section 3, Inside the brass nozzle.
Now, to truly grasp why this tiny bit of abrasion completely ruins your high-quality prints, we need to zoom in. It's not just a simple tube. These nozzles are precision-engineered. They feature a conical shape on the outside, but more importantly, a matching internal conical cavity. This specific tapering shape is meticulously designed to tightly regulate the flow of molten plastic, bringing it down to a very precise, narrow point of extrusion, which is often just 0.4 millimeters wide. Notice how the geometry of the wear plays out here. Because the internal cavity is a cone, imagine what happens when you sand down the tip. As it wears off from those 100 hours of abrasion, the narrowest, most precise part of that internal cavity simply disappears. Suddenly, the opening at the bottom of the nozzle is much larger and wider than the exact diameter your printer software is expecting. And this creates a disastrous chain reaction for your prints. Because the opening is now physically larger, it does a terrible job of regulating the molten material. The printer's extruder is pushing filament under the assumption that it's squeezing it through a tiny, precise hole. But because the hole is now wide, a much larger amount of plastic just sort of dumps out all at once.
This leads directly to a massive inconsistency in how the plastic is deposited onto the build plate, resulting in that frustratingly irregular, messy shape we saw back at our crime scene.
Section 4. The simple solution. The mystery is officially solved. It wasn't the monsoon, it wasn't your slicer settings, it was just physical wear and tear. Fortunately, the solution to this mechanical mystery is wonderfully straightforward: basic hardware maintenance. You just need to physically replace the printer nozzle. By swapping out the abraded part with a brand new spare, like the extra one that conveniently comes included with printers like the Allego Neptune 4 Plus, you can instantly test this hypothesis. It's a super quick mechanical swap that resets that internal conical geometry right back to factory perfection.
And just look at how this builds into our final result. We have our rough, ruined print from the worn nozzle compared directly to the exact same file, exact same filament, printed immediately after replacing the nozzle. Making that simple hardware swap results in a miraculous difference. The new nozzle perfectly regulates the material again, completely eliminating that rough surface and restoring the smooth, high-quality finish you absolutely expect.
So the crucial takeaway here is perfectly captured by this quote from our source material. If you're struggling with poor print quality, finishes that look chewed up, or inconsistent extrusion, you have got to check your hardware for wear and tear. We are all so quick to assume it's a complicated partial clog or that we messed up our slicer settings, but very often it is simply a physical nozzle that has worn out and widened over time. It is just incredibly easy to overlook these simple mechanical realities of our tools. So before you spend hours baking your filament in the oven and before you tear your hair out tweaking your retraction settings, ask yourself this: when was the last time you physically checked your nozzle's tip? Are you actually printing through a precision hole, or has time and friction turned it into an abrasive crater? Go check your hardware, swap in a spare if you need to, and happy printing.